Next, we're going to discuss how to calculate fill. Now, the fill is not going to be in fill area, that is, and the fill is not going to be exactly equal to the ramp wall area. And this is because, I'll switch over to the example drawing set. As you can see here, it's a good example of where similar to what Jay had explained, where the ground line meets the foundation. We don't necessarily need to excavate this area between the foundation and the anchor, the entirety of it. Although it may look like a little bit on the drawing set, any bit of excavation we can save on site is helpful. So this will be left as undisturbed soil area. Now I'll use a slight approximation for the purpose of just showing here, but what I like to do instead of calculating ramp fill area immediately is I'll calculate the soil area. So let's take this, say this is our ground line in green. We'll take this value to approximately here, where it meets the cables need to be dug out, back up to the ground line. This will be our approximate soil area. You'll need to get the exact soil area for exactly what your design may look like. And I'll use that area here of 4.3, and I'll subtract that from my ramp wall area, and that will give me my ramp fill area. So I'm only having to do one measurement and getting two different values. With the same method, we can go and calculate our ramp cap using the area function. In AutoCAD, and so on and so forth. And these values you can use for your quantity takeoff, and as I said before, they should be the same values that you're using in your design as well. So remember, if the design manager decides to raise the anchor a little bit and push it back, then your ramp wall, fill, cap, etc. areas are going to change. Now, you can consider building this as an automatic algorithm in Excel, instead of having to remeasure area every time. This is a little bit harder than expected because there are many different options for if the ramp wall is going to be flat and how you're going to calculate that extra ramp area. One thing I would recommend, and is linked below, is to use a polygon. So use other dimensions to set up each point. That is important to you for your abutment, and you can then calculate the area of that polygon. So as dimensions of your abutment change, you can automatically calculate an area without having to go back and remeasure. This can be a really valuable tool, although it takes a little bit of time to set up. Now, I won't go in this course how to develop this tool because it is not necessary and imperative for your design, although it does save time. But in the advanced design course, I do talk about how to create an automatic tool that can calculate various areas, recalculate various areas as you play with your design.